Let's play around with some hyperbolics today. What do we have for you, minions? We have a hyperbola, not a rectangular hyperbola, just generic hyperbola. This is the oval form for it. We want to show the tangent at a generic point, right? These are parametric forms of the hyperbole equation. Plug them in, you'll see they work. So a tangent at this point has this equation. Step one. We're going to find where that tangent meets the x-axis and call that point there P. We're going to find the tangent at the point A0. A quick sketch might help us with that. And then we're going to find where that tangent and this tangent meet. Okay? Then we're going to find the midpoint. So that will be the point Q where they meet. Show that the midpoint of PQ will satisfy this equation. Okay? So overall, a bunch of stuff going on. Let's see what can we do. What can we do? Got some coloured pens, we are set to go. So first thing that might be worth reminding ourselves is that this hyperbola looks something like this. It goes through here at the point A minus A, and it's got these asymptotes, y is b over ax. So that's the general scope of what we're playing with. So what we really want is, we're just going to take our generic point here, let's say a generic point here. It has a tangent, all right, it will meet somewhere here at P. We take the tangent at the point A0. We'll discuss that in a second. That meets at Q. And we want to find something out about the midpoint here of those 2 points and see what that satisfies. So that is our plan. That's our job. That is the mission that has been set. All right, step one. So just generally, let's think of this as a parametrization. We need to find the equation of a tangent. Let's find the gradient. So dy dx is dy d theta over dx d theta. Oh, that's a b. Sine theta. I swear I'm going to drop one of these h's throughout this question. Just type away in the comments, let me know where that happens. Right, so equation of a straight line. Y minus y1 is gradient x minus x1. Now what are we going to do? Let's multiply that up here. So we get a y sine theta minus a squared sine squared theta. Have I done a whoopsie? Yes, because that is a b, obviously. That is a b. So that's an a, b. I know what's going on. Multiply this out, xb cos theta minus, how poorly is this going for me so far? Because that is an a cos theta. All right, so far we are about 2 minutes into this video. I'm 0 for 3. This is going very, very well for me. Now, how did I know that I'd made a whoopsie there, right? As you can see, working on the whiteboard, there's a lot of scope for error. But how did I know that was going wonky? Well, if I look at what I want here, I want an AB, so I don't want the cos squared and sine squared, right? So what I want is to have ABs in both cases, so that told me that that B was wrong. And I know I'm going to be using that cos squared sine squared relationship to be able to get rid of them. So I knew I wanted a cos squared. So the clues are there to help hold your hand as you're going through these questions. Keep an eye out for them. Make sure that what you are doing has a sense of purpose, that you can sort of have a think about where it's going to lead in the next couple of steps, because that can be very, very helpful. Where do I want everything? So I'm going to move that there, I'm going to move that there. AB cos squared theta. And I can factorize out the AB minus sine squared theta is XB cos theta minus AY sine theta. Might get a bit of glare over on that side. I'll try and scooch everything over here. All right, and that gives us what we want. I'm not going to rewrite it. Space is at a premium because we know that cos squared minus sine squared is 1, which gives us what we want. Right, let's find out where this meets the x-axis, i.e. y is 0. Well, it's quite easy. We get AB is XB cos theta. Therefore, we get x is A over cos theta 0. Nice. Nice, nice, nice. B. Now, let's talk about this. The tangent at A0. You could go through the whole dy dx equals 2 at that point, all right? Because that is absolutely correct. And if you plug everything in, x is A, and you tidy it up, you will get what you need. However, you have to think yourself, what is theta in this case? And the point is at this point here, it's not any old point. This is the point where theta is 0. So you will have a bit of an issue here. You'll have a bit of an issue here. At theta is 0, what you basically get is you get dy d theta is 1 and dx d theta is 0. As we can see from our sketch, by knowing what this graph looks like, we can shortcut that because we know, because of the behavior of this graph, that at A0, the tangent is directly vertical. So we are just looking at x equals A as our tangent at that point. It's directly up. Or you can play around with these things. That's completely up to you. But I find, because we know what a hyperbola does, we can quote this. So I want to find where that meets this. Well, okay then. Why? What did we say it was? So we get AB cos theta minus YA sine theta is equal to AB. So let's move that AB over onto the left-hand side, move that over there, and I'll factorize out the AB. Well, that's quite nice. The A's go bye-bye. The A's go bye-bye. Boop, boop. So we end up with the point, Q is the point, X is A, Y is B, times cos theta minus 1 over sine theta. So isn't that nice? Isn't that glorious? That's the point we have. So I've got P here, and I've got Q here. Now what we want to be able to do is we want to find the midpoint of that and see what properties it has. So we really just need to find the midpoint. Now let's junk some of this away for now, because we don't need it anymore. So P, we said, was the point A over cos theta 0. Q was the point A, B, cos theta minus 1 over sine theta. And now we want to look at the midpoint. Right, midpoint. Is that C or D? That's D. Let's call it M. I don't think the question gave it a letter, but I will. So the x-coordinate is 1/2 of A over cos theta plus A. In fact, we can play around with that a little bit. Make this a get a common denominator here. cos theta and times that by cos theta. Factorize out the a, and I think we get 1 plus cos theta over cos theta. And that's already quite nice because I can see something else appearing in here. And the y coordinate is 1/2. We add these together, 0 plus b cos theta minus 1 over sine theta. And that will give me b over 2 cos theta minus 1 over sine theta. Okay. Now, we want to show you, now it's quite nice, we've got a very similar form for both of them. I don't know what's going on with my brackets. I don't know, I can have big brackets, I can have small brackets. Look, just for funsies, I'm going to put those brackets around there. We need to play around with that. Now, it's a show that question. So this is what we want to get to. Let's just use it. You look at this, there's nothing obvious jumping out to me that I should be able to spot as a relationship. So let's start with this. 4y squared plus b squared. 4y squared plus b squared is equal to what? That is 4 times b squared over 4 times cos theta minus 1 squared over sine squared plus b squared. Okay. What does that give me? Well, it gives me a few things. The b's go bye-bye. And then we're going to create a common denominator of sine squared, so times that by sine squared. So what do I end up with? I end up with b squared over sine squared times, let's expand this, cos squared theta minus 2 cos theta plus 1 plus sine squared theta. Now, what do we know? I feel like we should be able to do something with this, reminding ourselves that cos squared, let's remind ourselves down here, that cos squared theta minus sine squared theta is equal to 1. So that tells me actually that that is just cos squared theta. So this comes out to be b squared over sine squared times 2 cos squared theta minus 2 cos theta. Awesome. And now that is a squared. We've got our squared there, big chunky pen. Multiply that by x. Now, what did we say our x coordinate was? It was that. A over 2, 1 plus cos theta over cos theta times all of this. So what we're going to do is b squared over sine squared. Now, I'm going to factorize out the 2 cos theta from this, which gives me cos theta minus 1, because I can already see some stuff happening if I do that. So the 2 and the 2 go away. The cos theta and the cos theta go away. Oh, we should be able to get this done in one last line. So we've got the a, we've got the b squared. Now, 1 plus cos theta times cos theta minus 1, that is cos squared theta minus 1. All right, dots. Got some dots there. But cos squared theta minus 1, if we rearrange this, is just this little equation that just keeps on giving. Cos squared minus 1 is sine squared. So what does that tell me? These two cancel out, and I'm left with what I wanted. That x times 4y squared plus b squared is ab squared. Boom. Whew. Didn't really have much of a safety net for most of that. I just had to trust that it was going to work, and it did. Quite glad. So much scope for that to go horribly wrong. But we know sort of things with what we're looking at. This question is boiling around just using and abusing the relationship between cos squared and sine squared. So we knew that that was what we're going to look out for. A bunch of stuff was going to cancel out, and it's just about being a little bit careful. The one bit of intuition here is being able to shortcut a little bit that Q is vertically upwards. Go check things, how parametric gradients work as well. If it's going directly upwards, it's because dx d theta is 0. If you get that, you will be getting a vertical tangent. Awesome. If you found this interesting, do not forget to sign up for our Easter revision sessions. I think mine are on the 6th of April and the 13th of April. They should be Sundays. I might be out by a day there. But definitely on the Sundays, the 2 Sundays leading up to Easter Sunday. Check the link in the description. We get to hang out for the day. Get to hang out for 3 hours or so in the morning, 3 hours or so in the afternoon on those 2 days. Cover, I've based it largely around the edXL spec. So we'll be doing all the core pure, which actually is the same for all the different specs by a couple of minor tweaks. And then we'll be doing an afternoon of mechanics and an afternoon of statistics. So whatever exam board you are taking, whichever modules you are taking for your options, there will be something there for you. So check out the link down here and we can hang out for the day, chat about further maths, do a bunch of really cool questions, and make sure that you are spot on ready for your exams at the end of the year. I'm Nick. This was some really cool further maths, and I will see you next time.